Hey guys, Dr. Brown here. Today we're continuing the study of volume associated when you're revolving an area around an axis. So we have the same lines as we had yesterday. Y equals square root of x, y equals 0, x equals 3. So if we look at that, I have this is y, this is x, x equals 3. And y equals 0, that's my x-axis, so then I have some function, y equals square root of x. Okay, well, when x is 3, square root of 3 is y, so this point here is square root of 3, this is 0. Okay, alright, so we have that area bound by those three lines, and we're going to rotate it. Yesterday was around the x-axis. Today we're going around the y-axis. So we're going around y. Now let's start with the disk method. You'll recall the volume is pi times the integral from c to d of my outer radius squared minus the inner radius squared. In our case, we're going to integrate on dy because we're rotating around y. And also recall when they said in the disk method, put your, in this case I've got dy, the rectangle that represents your differential on y, dy, put it perpendicular to the axis of rotation. Okay? Now, what is my outer radius? Let's fill in the blanks here. I have pi times the integral from 0 to square root of 3. Since I'm integrating with respect to y, well, the outer radius, this is rotating around, it's 3. So that distance right here is the big R. So 3 squared minus the inner radius would just be x. So if I move up here and it's shorter, it's still the x value, whatever x is. But we're differentiating with respect to y. So y equals square root of x. If I square both sides, okay, that drops off the radical. So x equals y squared. So my inner radius is y squared. But it's y squared squared. Don't get tripped up on that one. Okay, alright, so I have pi times the integral from 0 to square root of 3 of 9 minus y to the 4th dy. Alright, so that equals pi times the integral, well, let's just integrate it, sorry. Alright, so I have integrating 9, I end up with 9y minus y to the 5th over 5, and all of that from 0 to square root of 3. So let's plug in our numbers here. So I have 9 times square root of 3 minus square root of 3 to the 5th. So we're going to raise this guy to the 5th power. Square root of 3 times square root of 3 is 3. Square root of 3 times square root of 3 is 3. Okay? Which is 9 times square root 3. So 9 square root 3 over 5. Now if I get a common denominator of 5, 9 times 5 is 45, square root 3 minus 9 square root 3, both over 5 times pi. So what does that give me? 36. So my volume is 36 pi square root 3 over 5. Okay. Disk volume 36 pi square root 3 over 5. Now let's look into the shell method and see if we can get the same thing. Have the same function, still rotating around the y-axis. So everything is the same except the method. So I have x equals 3, y equals 0. I have my function. There's my y-axis, y and x. We're rotating about that axis. Okay? We'll call this y equals square root of x, so this is still square root of 3. This is 0, 0 to 3 on the x-axis. All right, the formulation for volume in the shell method was 2 pi, the integral. Oh, and before we go into that, you're setting up, in this case, dx, that rectangle representing that, parallel to the axis you're rotating around. Okay? Now, since we're integrating with respect to dx, we're going from 0 to 3. P of x, h of x, dx. Well, what is P of x? It's the distance from the axis of rotation to the center of your differential here, to the rectangle that represents dx. That's P of x. Well, in our case, what is that? Well, it's just x. Okay? So, well, let's leave it here. P of x equals x. Now, h of x, now we're looking at what the height of this box would be. That rectangle is. That's h of x. The height of it is that. Well, what is the height? Well, the height is just square root of x. So h of x equals square root x. So now I have my volume equals 2 pi times the integral from 0 to 3 of P of x, which was x, times square root x, which is x to the 1/2 dx. So that equals 2 pi, the integral from 0 to 3. X to the first power is x to the 2 over 2, so I can add these guys together, which is x to the 3/2 dx. And that equals 2 pi. So let's go ahead and integrate. 3/2 plus 1 would be 3/2 plus 2 over 2, which is 5/2, divided by 5/2, which means I multiply by 2/5, and that's from 0 to 3. So 2 pi times 2/5. So now I'm raising 3. You recall the rule here, a to the m to the n equals a to the m times n. That's what I have here. I have x raised to the 5th power to the 1/2 to the square root. So let me take the 3 and raise it to the 5th power. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. That's 5 of them. So I have 9 times 9 times 3. But I've got to take the square root of all of that, which is the same as this. So square root of 9 is 3. Square root of 9 is 3 times square root of 3. So 9 square root 3. So that's 9 square root 3 minus 0 put in there, and that's just 0. So 2 times 9 is 18. I have 18 over 5 square root 3 times 2 pi. And that's going to be my volume. My volume equals 2 times 18 is 36 pi square root 3 over 5. 36 pi square root 3 over 5. So disk and the shell both give me that value. Alright guys, keep studying. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying. There'll be more to come. I think the next video we're going to rotate around 3. And then the following one we're going to rotate around a number out here, a 6, let's say. And get to where we can use the shell or the disk, because there are advantages each have based on what the function is. For example, in this one, in my mind, it's easier to differentiate with respect to x. That just worked out better for me in my head, okay? But some functions, depending on the shape, you may have to have two integrals using one method, but only one integral using the other. So it may simplify. So learn them both. Okay, that's all for now. We'll talk to you next time. Thanks.